This is actually a mixture of soil and a chemical. So what we do is we put soil.
And what size are these? These are 50?
20 mil.
20 mil.
Right. There are actually two sizes of the vials. This one is 20 mil. This one is 10.
Oh, okay.
All right.
Right.
But for SPME analysis, it's better to use 20 because this one has a very shallow depth. It's not ideal for
I see.
the fiber. One thing keep in mind is if you're dealing with soil, now because the fiber
Okay. We need to see that.
Right,
So the
right.
so these are our fancy. You recognize them. There are three that we'll tell you the story about this sometime.
Okay, one particular
Now wait,
reason-
before you go, I want to know where do you get this little blue thing again?
I don't remember actually.
It didn't come with the pencil or the
Oh,
eraser.
okay, that's the cap for HPLC columns, I guess.
Oh,
have two caps.
oh, okay.
What we did is we talked around and we measured. See, that's the SPME fiber. We measure the protrusion here and make a hole equal size. And this one is just what I get from any store. You can,
It's a little pentel eraser, right?
yeah, pen
Holder.
eraser. So we take out the eraser. We use the other end. See, that's pretty nice.
Okay, so when you put it in there, you have the little trigger pulled back,
Right.
and you drop that in,
Drop that in.
sort of center it, and then put that on.
Now, one thing about handling fiber is never use excessive force. When you do that, you end up breaking the fiber. I'm going to show you that in a minute. Not breaking part, but showing you which part can be broken. One reason you want to have always prepare, if it's soils, always prepare 10 grams at least. Like in this case, I have 12 grams here. The minimum is 10 grams, and the reason being is
Okay, wait. I don't know how we're going to watch this. So, you're putting,
right.
we have a septum. By the way, what kind of septums are those? Those are
PDFE septum. With
PT, PT, polytrifluoroethylene or something.
Ethylene, right.
They're Teflon.
Right. See, because using our manual fiber, I'm not pushing the fiber out at the moment. I just
Okay,
want to
so
show
this is
you.
the case.
I just want to show you. See, you got to have 10 grams of soil, so that you can actually have the fiber. You can have the outer steel syringe needle to go in.
Wait. You mean to make it down to the fiber?
Right.
Or
The
into
idea
there.
is when you expose the fiber, it should be completely covered in
So the small ones would solve that problem, but then you run into the trouble of.
You're going in too deep, you see.
I see. So, but we could fix that by doing some sort of support on top.
Yeah.
Okay.
Yeah, but see, if you're handling like, doesn't take many. If you're handling like 6 or 7 symbols at a time,
Right.
I'm pretty sure you're gonna be very busy. That's why I always use this 20 mil. The other thing is, if you ever want to do head space analysis using that analyzer, it's easier to use 20 mil.
The 20
ones.
mil ones. Okay, head space means you're analyzing the gas in the head space above the sand or soil, dirt.
Okay, let me show you. We have 2 different holders. The expensive one, it's $170 a piece. This one, 99 cents. Alright? This is what Supelco made.
So Pelco's where we buy the fibers from.
Now there is a difference between these 2 holders. This one you can only use it for sampling, but when you need to do the thermal desorption on GC, you definitely need to use this holder. The way you do it is, alright, there's a thread at the bottom here,
Okay.
also a thread on the hop at the top here.
Oh, yes, okay. So you screw that into that little black part.
By the way, different fibers, their hop have different colors. That's just a way to identify the coatings on the fiber.
So you screw it into the black part. I see. Okay.
Okay. Hold it in. Now, one thing you want to make sure is, see, this is a outer needle. There's another needle inside this hollow needle. As you can see, in the spring, there's a pretty thin needle. So when you move them around, make sure you don't bend them, because once you bend them, the inner needle just wouldn't come out.
Okay, then you put that little device in. And it has just a little hole in the center so the needle can do. Lines up, screw it on. And so now you push the, I don't know if we can see that, but anyway, you push the fiber out by pushing the plunger.
Right.
You can see it.
Okay. The idea
And this
is,
controls, go ahead, Chad.
right. The idea is when you let it sit on the top of the GC injection port, you push this down,
Zoom in, okay.
lock it in,
Gotcha, okay.
so the fiber will be exposed in the GC injection port, and the chemical is absorbed by the fiber here will be thermally desorbed. How far the whole needle will go? Well, in this case, there's a depth gauge here to tell you how far. No, better put this one up first.
Oh yeah, finish. Okay, so this is the outer part. And the outer needle now comes through.
This gauge controls how far your needle actually will go into the injection port. As I said, see, there's a gauge, there's a scale on the surface here.
Oh.
I usually choose to let the needle go in 4 centimeters in depth.
Okay, 4 centimeters.
That's
Gotcha.
just the depth I use. You know, all right.
And you can move this little ring so
Around.
that you don't have to constantly.
Another piece of information: if you ever wear down this ring, don't buy it from Sapalco. We can have the same ring here, just used for GC liners. By the way, this drawer is for all the supplies related to gas chromatograph.
So you use what? You use the GC
Yeah, GC O-ring.
O-rings. Oh, for that.
A lot of that. Doesn't cost you a penny, but if you buy from Sapalco. CAD space analysis tools that here,
Okay.
including the caps, septon, and I took them out this morning already. Otherwise, those crimpers and decrimpers,
Okay.
they're here.
For crimping the caps on.
Vials down here.
All right. Good.
Okay. So the next thing usually I do before using it for any sampling is you want to actually clean it up.
Clean it up.
Yeah, don't use any solvent with these fibers. Not in any
Okay.
situation.
So now you're injecting it into the injection port, and
That's what you
you've
need to do.
lowered it to there, and you're just letting it sit there at temperature.
Sit there, and then you want to use 250.
250 for the front inlet.
Right. You only let it sit there for 20 minutes at 250 degrees.
And
Right.
so basically, okay, so you're conditioning it basically.
You're conditioning it. And you will see it actually, if you haven't used it for a while, it tends to absorb things from the air.
Sure.
So,
Okay.
you definitely
Okay.
want to do that.
That's a good tidbit to know.
Now, this is an aluminum cap. It just serves as a holder to hold these pieces on top of the vial. There's a color side, there's a white side. White side is the PTFE.
PTFE side, the Teflon side, so
Right.
that goes inward.
It goes inward.
And the reason we use Teflon is that hopefully our organic chemicals aren't absorbed onto it very well. So we're not losing chemical into the cap.
Alright. Then it's ready. This is the crimper. Don't mix that up. This is the decrimper. Very easy to tell. This one is hollow inside. Alright.
Okay.
That's how you. When you're crimping them or decrimping them, make sure the screw goes to the bottom of the base. That gives you the tightest grip. Right?
Okay, so the screw nut here is down to the very bottom.
Right, you can pull it out if you want to. See.
Okay, if you don't want to crimp so
No, you don't
tight
want
for
to do
some,
that.
we want it crimped tight, yeah.
Right?
Okay, so that puts the cap on, and then whenever it is you want to take the cap
The
off.
reason I said don't mix them up is, now that's why you always want to lock them up after use, so it's easy to tell them apart. Otherwise, look.
Oh, I see. Okay, so you want to close them, and then it's easier to see.
Right.
Yeah, I see. The little locks.
You know, this is kind of fun. Never talk.
Shen has
All
a
right.
strange sense of humor, that's all I can say. Okay, going on.
Decrimper. This one you got to use some force there to take them off.
Okay.
That's when you need to take the soils out. So this part is done. Then we get into how to do this. Oh, the
Okay.
different coating. This one is pretty thin. It's only 30 micrometers.
So this one is the yellow one, right?
Right.
This was
one-
yellow, and so this was silicone rubber, basically, coating, right?
Right. This is right.
So this is the
That's
PDMS, polydimethylsiloxane, better known as silicone rubber.
okay. Here's the tricky part. Because that fiber is too thin, it's very easy to break. Now, even that with what I'm showing you here, you might still break it, but the chance is slightly better. You let it go in. By the way, when you want to poke a hole on it, you put the fiber in the holder. Just let the needle come off a little bit. That should do the trick.
Oh, to get your initial hole.
Right. Never use it this way. Try to poke a hole.
Oh,
on the
I
septum,
see. Okay.
Because you're gonna bend the needle. You don't have
Okay.
to break it. Bending it will make it unusable.
Right. Okay. So you put a hole in there, and then you keep putting it more or less through
Right.
through the same hole.
Right,
And
you can
so
see
then-
it already.
Okay. Wait.
Can you see it?
Yeah. Now I can. Okay. So there's the needle in the hole, in the soil. Okay.
Then you let it go upside down. Force your needle to go through. Don't let the fiber out at the moment. Okay, because these are see, the fiber is not designed to work with solid. That's why they are very thin and easy to break in solid. So you want to make sure. See, because it would dangle on the top. This is what I usually do.
So
I tape around it.
as you can see, this is a really high-tech process.
See,
But you want it so that it's
at this
stable, right?
moment, yeah, at this moment, the fiber is not out.
Right, it's still in the inner, or it's inside the outer needle.
Right? See, it's not out. And you let it sit flat on the bench.
Focus.
Now you can see that actually the fiber is pretty thin, and there's another inner needle next to it. You probably won't have it on the tape.
Right, so now you've pushed the fiber out. Yeah, I can't seem to get it to focus. We can see it, but it's pretty blurry. Oh, now it's really blurry.
Alright, the reason I have dingy tape is,
There.
remember this basically is a eraser holder, so these pieces, the clip here tends to go back up, you know, with the help from a spring on the fiber. So that's the way
Oh, so you
I
tape
fix
it so that
Right.
it can't. Yeah, I see.
Okay, so the fiber is totally out there.
There we go.
The next step, you want to be kind of,
So then you sort of gently stand it up, let
Right.
the soil drop back around the fiber. Now, when
Okay,
you're
and don't
doing
move
a
it around.
kinetic study, time zero is when you stand it up. I see, okay.
there are 3 channels here.
For your timer.
Right.
Okay.
Then you let it sear. It's basic. Well, one thing you want to check, and this one is pretty good now. You can see there's no opening surrounding the fiber.
Oh, I see.
If you let the holder dangle on the top there will be some empty space around the fiber, then you're not doing any direct sanding.
Or you might not be. So you jiggle it or something a little bit to get the...
That's easy. See?
Yeah, okay. Gotcha. A little tapping.
All right. I have one.
Now this one's already...
Now this part is kind of tricky. Now the idea is you want to take off these tape first and retract the fiber, and then after the fiber is completely retracted, you'll remove this piece of tape.
I see, okay.
Right.
So this is how you end the sampling.
Right. This is the part this is the part I would imagine generating most person-to-person error, because it really depends on how fast you can get this down.
Well, that would only really matter if you were doing really short times, right?
Right.
Okay, so first thing you're doing is taking the tape off, and you're trying to be careful so you don't wiggle the fiber too much so that you break it.
Right. Once this one is off,
Then you unretract.
I'm doing it slowly because the fiber has been in the soil for quite some time. You want to make sure it's retracted slowly so the coating wouldn't be damaged by any fast action. Now, see, the fiber is not totally up yet. So what you got to do is...
because the spring didn't come up.
Right. Sometimes using a pencil is a lot easier. That's what I'm going to see.
It's really high tech. This is the advantage of the expensive holder, because this doesn't happen.
Oh, but considering the price, I would say this is pretty good. Actually, I think the fiber is pretty much out already.
So you think you're now up high enough?
Yeah.
Okay, so now you untape that.
See? The fiber is all.
Yeah,
You can see
okay,
it, right?
good.
It's been retracted. The other problem with using this manual holder is you definitely want to hold out a bit to allow the needle go back straight.
Oh, right, because sometimes it gets kind of curled, doesn't it?
Right?
Now you put it in the sample holder.
Push it in.
And that part goes in.
See, my fiber is still there.
Right.
It's $63 a piece for that fiber. I think 55 or something for this particular kind. So it's unavoidable, you know. Eventually, you're gonna break.
What we do with them isn't what they're designed for. Obviously, they're
Right.
designed for liquids.
Or use
Although
for liquids,
we may
so.
have Dan do some of the slurries we wanted to do. We may have
Alright.
Dan do that. So that'll be.
Then before you do the analysis, you want to rinse it with water. Now, if you're sampling directly from powder chemicals, you're gonna have a lot of powder sticking to the fiber. But since it's soil mixture, so it doesn't really matter.
Right. So you do a quick
Right.
rinse.
Great. It will come off, anything on that. Never put it under the faucet. Okay, that's one way to break the fiber.
And how do you know that?
I experimented on it before.
Okay.
Okay.
So now we take the fiber over to the GC.
Right. Okay.
Let's see. Hopefully. Okay, so you're going to put it in the port.
Right. I always use both hands because I don't want the needle.
To bend.
Yeah.
And so you've adjusted it to the right position. You said 4 centimeters.
4 centimeters.
And so now you're set to.
Don't wait too long because it's thermally desoaking already. Then start, manually start. Okay, see, then it's sampling in progress. Manually start because that's how manual operation is done. Although the data collection is done by cam station.
I see. So the program's sitting there ready to go. So when you push start, it says, okay, we're ready to go.
Right.
And now it's doing the 3-minute, sitting at 45.
Right. You can tell by seeing oven. The temperature right now is in the first 3 minutes, so it's only 45 degrees, but later on it will just come up.
I see, okay.
Actually, you can let it sit there more than 3 minutes, but the minimum is 3 minutes.
Okay. We're not, okay,
Yeah.
now we're recording. Okay, so now you have 2 fibers.
Right. Just to show the difference, we have 4 different types of fibers.
Okay,
Like I said, they have different colors on the hub.
okay.
Alright. This one, the blue hub is.
That's a
30
yellow one, I
micrometer.
think.
Yeah, I'm sorry. The
Yellow one.
the yellow one is 30 micrometer polydimethyl siloxane.
Right,
It has only one coating.
okay.
Now this one has a thickness of 65 micron.
And that's the blue one, right?
Right, that's the blue hub.
Okay.
Made of polydimethyl siloxane and
Divinyl benzene.
divinyl benzene, yes.
And what's that one for?
That's used for TNT and DNT and dichloral
Benzene?
No, I'm sorry.
Dinitrotoluene.
Right. And trinitoltoluene analysis.
Okay. This is our army work. That's munitions. They're worried about munitions contaminated soils.
See how different they are compared to the other one. This one's whitish and looks by appearance much thicker.
Okay, so that one's for the TNT, DNT.
Right.
What do you use for cyanophonol?
Four cyanophonol is.
You use the yellow one for naphthalene
Oh, okay.
and phenanthrene. Is that right?
Thank you.
Oh, we have action on the GC. Oh, there's
That's
our
all of
peak.
that.
What was on that soil?
Naphthalene,
Oh, okay, that was naphthalene contaminated soil.
right?
All right.
Okay, lower your lens here. I haven't put on a label.
All right, the unlabeled drawer right under the monitor.
This is the most expensive drawer in the lab, so.
I don't think that's actually quite true, but
No, considering single drawers, this is very expensive.
okay.
This one is 7 micrometer polydimethyl siloxane. Remember that yellow hub is 30 micrometer.
Oh, so this is a thinner coating of silicone rubber.
Right. If you want it, see, one problem is if you want to quantitate it. Right now, we do our study by comparison, compared to the saturated aqueous solution. So it doesn't really matter. But if you want to have a quantitative number, they recommend you the very first thing you do is make sure to look into how long it takes your fiber to equilibrate your samples. This fiber typically is used when you want to have a fast kinetics, and the coating has a pretty good affinity, can absorb a lot of the chemical on the fiber in a short period of time.
Right.
It's called bonded phase. There are 3 different phases. Mainly, for most of what we have here, it's bonded phase. When I mentioned you don't want to use solvent to clean the fiber, don't do that to bonded phase. Bonded phase is not the one. It doesn't tolerate any solvent at all. Okay, so this one has a.
Oh, so green. Green is the 7 micrometer thickness coating silicone rubber. Okay, what else? Carbowax, right?
Right.
So we aren't usually using the 7 micrometer ones. Is that right?
Excuse me?
We're not usually using the 7 micrometer ones.
Yeah, we use it for dichloral benzene.
I see, okay. in the soil.
It's supposed to be used for benzoyl pyrene too.
Oh, okay, so we still have that to do. We may do that. Okay.
Okay, that's for 4-cyanophenols, 65 microliter carbowax, and divinylbenzene.
All right. This is for cyanophenol.
Right?
And what color is it? It is red or orange.
Orange.
All right. Now we have some of these fibers for the LC too, right?
Right.
That we haven't used.
No, it's the same thing.
Okay. All right. Anything else?
Oh, let me see that. Oh, we have 4 fibers. That's the holder. That's for HPLC. That's
So-
the holder for HPLC.
Okay. Which is just slightly different
Yeah, it's,
dimensions, probably, right?
yeah,
It's just.
it's not very different. The whole idea is that one is a manual holder. This one you have to fix it up on HPLC. So it's not really a manual holder in a sense. It is a holder, but not
Oh.
really manual. So.
The LC does it still, right?
Right.
I see. Okay. And that's why we have an attachment for the LC.